What's going on, y'all? Sean here, and in this video, we're going to get into the topic of curve sketching, more specifically analyzing a graph of the first derivative. Okay, make sure you like and subscribe. All right, so if you look at this curve here, what we have is a graph of the first derivative of some function f. Okay, now the key with these kind of problems is really keeping track of whatever what you're looking at. Again, this is not a graph of f. This is a graph of f prime, the first derivative. Okay, this really kind of starts to like exercise um your mental skills of being able to kind of like hold this kind of information in your head and know what you're seeing and think between derivatives, function, first derivative, second derivative, that kind of deal. So just take your time and let's go ahead and get into it and answer these questions. All right. So first question is, on what intervals is f increasing? Now, this is f prime. This is not f. This is f prime. So remember, f prime being the first derivative, if you look at the graph of a regular function, the graph of a function is going to be, let me actually get the color blue here. Let me see something. Yeah, I just want to use blue. All right. So the graph of a function, where is a function usually increasing? When a function is increasing, it's going up. And what's true of the derivative in that point? That means the function, the first derivative is positive. Okay. And so like literally, if since this is the first derivative, it's positive everywhere that you see the graph above the x-axis, right? So that means that the function, based on what we see with the first derivative here, the function is increasing in the following intervals. That's going to be between 6. So I'm going to write it this way. So it's increasing between -6 and -2, and it's also increasing between 2 x is between 2 and infinity. Okay. Why again? It's because this is where the first derivative is actually positive. That helps us to quickly answer the second question, where is f decreasing? So it's decreasing between -infinity and -6. And it's also decreasing between -2 and +2. I actually probably need to take this off here. Let me take those off. A lot of times people use interval notation. I'm just not using interval notation. It'd probably be better to use that. But anyhow, again, it's decreasing because we see that the first derivative is less than 0. Okay. Now, next question. Where does f have a local maximum? So keep in mind, what is a maximum? It's basically like the top of a hill. Whenever um, the function f has a hill. Now, if you're thinking about function f, what is true of the first derivative whenever you have a maximum with the actual original function? Wherever you see a maximum, the first derivative is equal to 0. Where on this first derivative graph is it equal to 0? It's equal to 0 everywhere it crosses the x-axis, right? Because that's where y is equal to 0. So, but specifically, it has a maximum when the first derivative is positive, then it goes to 0 and goes to negative, okay? So where is the first derivative positive and then it goes to negative? So it looks like right here. I should have used a different color because the first derivative is positive and then it goes to 0 right there and then it goes negative. So that is, let me get my color back. I wish I had written in that before. But That is a maximum because the first derivative starts positive and then it goes negative, okay? So at x equals -2. Now, that's not the case here because it goes from negative to positive, okay? That is a minimum. When it go, that's like a valley. So whenever it goes negative, then to zero, then to positive, that's a minimum. Okay, so that's going to be at x equals -6. And also here too, it goes from negative to positive at x equals +2. Okay. So again, keep in mind what we're talking about here. We're looking at the first derivative and then making um, some conclusions about the original function. All right. No, I don't know what number. Well, this is number 5, I guess. What intervals is f concave up? Now, when we talk about concave up, so basically concave up is like um, it's like a U shape that's pointed upward, like the letter U. Okay. So on what intervals is f concave up? When is f concave up? So first of all, it has to do with a minimum. Okay, it has to do with a minimum, but it's basically like when is the function a U shape in what intervals? Okay, so since we're talking about that being around minimum, so it has to be around x equals -6 and x equals 2. Let's go to x equals -6. What intervals is it concave up? So it's not going to be concave up the whole time. It's specifically concave up until it starts to transition from um it comes out of that minimum and maybe gets ready to go into a maximum, if that makes sense. Okay? And so what happens is this is going to be okay, let's see. I didn't actually we're going this is going to be this graph is not drawn to scale, y'all. So we're just going to kind of like say that this corresponds to 4. Okay. Now let's say that this is 5. Let's say that this is -4 right here. Okay. All right. So what happens is this is concave up. Let me see. So this goes from negative to positive, which means you have a minimum at 6, -6 that is. And then by the time it gets to this point, up until it gets to that point, it is concave. Um, it's concave up because think about it. It's a minimum value. This is the minimum, so that means it's the bottom of the U shape. Then it kind of starts to go up, but it's at this particular point right here at the top of this f prime graph that it actually starts to switch from being concave up into being concave down. So the intervals are from negative infinity to -6. That's when it's concave up. And then again, if we think about it, let's go over here to 2. So again, this represents a minimum value at at x equals negative, x equals +2. So, but before here, when it gets to x equals 0, that is going to represent a point where the the function is going to go from really concave down to concave up. This is where it starts to go into that minimum right here at x equals 0. So this is going to be from 0, x is between 0 and infinity, to be honest. Again, because that's where the graph kind of starts to shift from, it first starts to go into that concave down point, and then it's concave down it's an upside down U shape the whole time. It's because the graph just increases forever and ever at this point. It doesn't ever kind of crest again as far as we see, then that means it's concave up the rest of the time. So where's it concave down? So again, so the first one, so we knew that it was concave up between negative infinity to oh, I oops. I said, I think I said it and then I wrote it wrong. It's supposed to be -4. So it's concave down from -4 to 0. Okay? Because think about it, if this is our maximum, remember, um, concave down, there's a maximum in there. And so it first transitions to concave down whenever you get to this point right here. Then it starts to go into that concave down shape until you get to the maximum concave down until it starts to shift down here at the bottom. Okay? So that's going to be between x is -4 and x is 0. Now, these points at x equals -4 and then x equals 0 are what we call points of inflection. That's where it changes from concave down to concave up. Now, let's think about this. How do we know, looking at the first derivative, that these are points of inflection? Because what happens is, so for example, looking at x equals -4. Well, that's really, you could also say this is -4 or 5, right? Now, even though the first derivative is positive, 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 it's positive this whole time it's above the x-axis. However, it's becoming more positive then when you're on the other side of this. That's when it's becoming less positive. Okay? And so it's not going negative, it's just that it's slowing down. It's increasing up the hill, then it's decreasing in its positivity down the hill. So if you can imagine, that means that since this is a maximum here, that means it's increasing, increasing, then decreasing, decreasing, then it gets to a maximum at this point down here. Okay, this being f, the function f. So a point of inflection represents a point where the graph is either more, it has been maybe increasing in positivity, then it starts to decrease in positivity, which means the function is kind of about to approach a crest until the function reaches a maximum where the first derivative is equal to 0. And then of course the same goes with the point of inflection down here. What happens is the first derivative has been negative the whole time, but it's increasing. I mean, it's decreasing rapidly until it gets to this point. Still decreasing on the other side of the point of inflection. However, it's decreasing more slowly, which means if you look at function f, that represents is maybe decreasing fast, then it starts decreasing more slowly, 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 then boom, it reaches a minimum. Okay? If that makes sense. Let me know if that makes sense. This stuff really exercises your brain, but once you really get the hang of it, it's fun. So you want to practice a lot, okay? You really want to practice a lot so you can get used to it. Let me know if this video was helpful. Make sure you like and subscribe and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.